Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we discuss our latest data research in a topic related to app development and back-end services. My co-host for the show is Donnie Berkholz of 451 Research. SignalFx is the sponsor for this week's show. SignalFx is a SaaS provider for monitoring modern applications. You can find them at signalfx.com. Now let's get to the show. Hi, I'm Alex Williams, founder of the New Stack, here for the New Stack Analysts show, back with Donnie Berkholz, my co-host, who's now with 451 Research. Good to see you, Donnie.
Good to be back in a slightly different role.
Yes, for sure. And I'm also joined by Phillip Liu, founder and CTO of SignalFx. SignalFx is a sponsor of the New Stack. Phil, great to have you here.
Great to be here.
Excellent. Before we get started, I want to just give a little description of what I'm thinking about talking today. In particular, I'm interested in how monitoring is moving to the center of kind of the application development and management universe. And so it's a pretty broad topic, but I'm very interested in kind of the SignalFx perspective on that. You guys push out a lot of blog posts about how you're using your technology, and I'm curious why you do that and what you're seeing with users and what are the experiences they're having. And so I thought that would be a good start for our discussion, and then we can go from there. But before we do that, Phil, could you tell us a little bit about SignalFx?
Yes, SignalFx is software as a service. We're set out to solve the monitoring problem for modern distributed applications. And a modern distributed application is basically a pretty complicated beast that's generally been created within the last 7 years or so, that comprises of many microservices. And generally, all the services which are on the web today are using this type of techniques to build their backend.
Okay, great. So Phil, let me start with you and then ask you this question. You know, I do see on your site you post a lot of stories about how you use SignalFx and how other companies are using, monitoring technologies, including Yelp. And I'm curious why you're doing that. What's going on with the users out there right now? And what are they experiencing, and what are they looking for from those internet scale companies that have been doing this for years?
Yeah, I think it helps to sort of step back a little bit and talk a little bit about this notion of a modern application. And I think one of the key things is that the modern application, we're seeing a proliferation of server or virtual machine or container instances out there. And so this basically, if you sort of look back a few years, you see a lot of with the advent of AWS, it's very easy for you to create a virtual machine now. And the virtual machine is basically sized for your application. So no longer are you in a world where you have big metal servers and you have many applications running on the same physical server, right? For the developer, the abstraction is that the server fits my application, so therefore I think about my application instance. And so as a result of this, you have a lot more instances out there. So that's like one thing. The other thing is, because now it's very easy for you to create a virtual machine, you no longer have to build these monolithic application servers where the application server comprised of many different components and you deploy the application all at once. Instead, you will basically build small microservices that's deployed that can talk to each other over the network and over a structured API. So now you have more instances on the network. And then coupled with this, since your instances have to be up and running all the time, and you no longer probably have an operations team the way you had like 5-10 years ago, the engineers today are responsible for running their own applications. So you design your application to be more resilient. So there are more instances. So if one goes to go down, if AWS would shut down one of your instances, you want to make sure your service stays up. So now these three things coupled together means that there was proliferation of all these instances. So if you then look back, well, now you have, if something were to go wrong, where do you start? So you have hundreds of instances talking to one another, tens of services talking to one another, who's responsible for fault is actually not as easy as it was just 10 years ago when there were lamp stacks around. So we're seeing a lot of that in the market space. So people just don't know where to start. There are actually a lot of great tools out there that tell you what happens when a particular instance goes down, but doesn't give you an insight about how the overall service is doing. So we're creating these blog posts basically to talk about how we, SignalFx, uses SignalFx to find out what is wrong with SignalFx. And some of the techniques that we use in building SignalFx are the same techniques that we use, from our past days at Facebook, at Google, at Yahoo.
Okay. There's a few things there that I'm interested in following up on, Donnie. I'm curious on, what you're seeing with that intersection of companies having a lot more instances and the simplicity it is to kind of make a VM, and then that kind of aspect of designing apps, and how that's kind of changing and how that's being affected by kind of these dynamics that Phil's talking about.
Yeah, definitely. I mean, I think those are two really interesting questions to dig into. The first one, I think, is this really happening yet? I mean, I think the best measurement of that is going to be, are enough people running into this problem to get SignalFx some customers? So maybe they've got some stories to tell on that. But I mean, certainly the early adopters, right? The people who are going to start picking up SignalFx first are going to be a lot of people living in this Bay Area bubble that I've spent, the past couple of years talking about, right? Where it's not geographic, but it is a distinct community of people who, pay attention to things like Vagrant, things like Docker, who have been playing with them, who are thinking about how do I deploy apps this way, right? It's really a distinct community from sort of the standard enterprise IT, which by and large hasn't picked this stuff up yet, will eventually, but isn't there yet. And so, if you think about who's doing this stuff and is it happening, it's absolutely happening, but at least what I see is it's mostly happening at startups, right? Or at people playing around in their free time, or, maybe there's a few sort of bleeding edge type folks inside of these larger companies, but they're not able to convince the company to pick it up yet. I mean, there are always exceptions to everything, right? Nothing's a rule, but that's the kinds of Docker adoption I'm seeing. I mean, one good example is, so the open source data center conference was happening in Berlin over the past couple of days, and I was following the tweet stream. And at one point, the speaker asked the room, who is running Docker right now? And 0 people in the room raised their hands. Right? I mean, we're talking pretty early days on this stuff. I think it's gonna come, right? I mean, just looking at the advantages of being able to containerize, being able to move toward this microservices approach, it's going to happen. And it's a great time, I think, for a startup to be able to get into the fight and hopefully, dominate the early markets so that you can continue owning it as it grows later.
Yeah, I think so. I think you may be right about Docker. The Docker right now definitely is a hot topic here in the Bay Area. But you're right that it may not have reached the level of adoption across a lot of companies. We use Docker internally ourselves, but I'm not sure how widespread that is. However, I think more to the point is microservices itself is actually taking off, not necessarily with Docker, but definitely within AWS. So with AWS, there are tens of thousands of businesses running their services on AWS. And I think Netflix, as a matter of fact, did a very good job a few years ago documenting and describing how their service work on AWS. And a lot of companies actually are following suit. One of which, like Yelp, which is one of our biggest customers, adopted this philosophy. They actually have services running in a mixed mode within multiple data centers. They have a lot of microservices talking to one another, and they also leverage AWS for scale-out capabilities. So that's definitely out there today, and we have a rather large roster of potential customer and trial customers, which falls into similar categories. And some of which ranging from startups, like as you suggest, and here in the Bay Area, all the way to Fortune 500 enterprise companies in the financial space and the health space and in the broadcasting space.
So you're seeing, that's interesting. So you're seeing it being used more so in AWS. Can you talk a little bit more about that? I'm curious because I don't often hear that perspective.
Yes. With last 7 years, there's been a major shift, even within enterprises, in how they think about infrastructure. Traditionally, it has been a very process-oriented function. So, there are the IT organization responsible for building out physical data centers or leasing physical data centers, getting network bandwidth, getting power, getting hardware devices into that location. And AWS has actually proved that that's not necessarily an in-house functionality anymore. And people can actually effectively use an abstracted interface to get hold of infrastructure. So therefore, the infrastructure service has certainly taken off. And enterprises are very much adopting to this philosophy. Now, whether it be OpenStack or whether it be something that they build internally, IT organizations operationally are shifting to this world where they're offering APIs to developers who then own everything up from the API level. And so that's also a nice way for them to create a contract between who's responsible for what. So that is definitely happening. So as a result of this, IT is operating a lot leaner than they have in the past because they're taking less responsibility on the operational aspect of applications that run on their infrastructure.
Okay, they're leveraging this scalability. The scalability is an interesting question that I have. Like, Donnie, in your experiences, are you starting to see enterprises ask more questions about scaling, and are and what are their what are their fears, but what are they testing out? Those ones that they have actually trying these different things.
Yeah, it's an interesting point, and I saw somebody, I forget who it was, tweet the other day that it's actually just a game until you can scale, right? Like, you're not enterprise friendly until you do have a solution that can scale, because that's the scale they're operating at. Thousands of servers, tens of thousands of servers. Whether they're in their old data centers or they're in the cloud, it doesn't really matter, right? But I think there's two questions when it comes to scale, right? One is, can you simply scale up? And two is the agility at which you can scale back and forth, right? Like, do you have very time dependent or other kind of load dependent stuff where you want to be able to, go from 100 servers to 1,000, maybe because you're, Zen coder and you suddenly have this huge encoding workload or something like that, or your Netflix, right? Which is the canonical example. Like, every night people get home, crash on their couches, watch Netflix. And so you have to have solutions that scale up and scale down. So I think, and that's a very different question, and one that's much harder in a lot of ways, versus the initial question of, like, do enterprises scale up? Absolutely, they're always at scale.
Right, they are always at scale. The question is, the one I have is, how cemented they are in their infrastructure, so they can even make data portable in any kind of manner, where they're not even, they're just struggling with these ideas of how do you move this data around. And if they're having those kinds of struggles, then I wonder why, Phil, they would even need these kinds of solutions that you're talking about.
Yeah, I think moving data around is definitely one struggle they have. I would characterize them more as like there's a new category of applications they're creating to satisfy these new, like the mobile devices that's taken off since 2007. The application they built as a back end for these mobile devices are new applications. And these new applications are accessing traditional old data, yes, but the new application are built in such a way that are in a microservices type of architecture. And what we're seeing is that these digital media groups within enterprises are the ones who are the consumer of a service like ours. And then in that world, they're building, they're taking a cue from the large web scale companies on how they build their internal services, and they're sort of following the same patterns. And these patterns basically then require them to, they want to move fast, like a Facebook, like a Google, and then they want to be able to be resilient and be able to scale it horizontally in case the application do take off. So the same rationale used to build these microservices, so they're what require the same set of tools to operate them.
That's something that I see a lot of too, actually, is, you know, if microservices, like where they're going to take over first is in new applications, no question about that. But, you know, the big challenge with them is all the tooling around them, right? Like people are coming into these things. Yeah, and maybe you are getting people coming in from, you know, finance, from broadcasting, whatever, and they say, oh, hey, we want to do this microservices thing. Now what? Right? There's like no starting point unless you just sign up for a PaaS and they say they give you microservices, right? So all the tooling around like how do you build microservices, how do you monitor microservices, how do you debug microservices? All of that is an enormous challenge for everybody who's trying to do it today. You know, most companies don't have experts in distributed systems, for example, right? And all that has to change, right?
No, absolutely. Because I want to sort of extend on that, and I think that what we're seeing right in this environment is that because it's the reason why people build microservices is easy for them to add components onto a service that's already running without taking down the entire service and be able to add piecemeal functionality to a service. So that's the way they organically grow. And then that's great to get going really, really fast. But the problem is that over time, complexity also grows along with it. And due to this complexity, and that's where you need to start to look at things from a data perspective. So this is where you need to start collecting information across all the instances of your services to use the analytical techniques to know what is happening with your runtime application. So I think that's where we come in.
Yeah, so I'm curious then, how are you seeing these users building microservices environments? Or, you know, because you know, when we write about microservices quite a bit, but it's most of the time it's in a container perspective, right? But you know, as Donnie, as you said at the top of the discussion, you know, even Docker isn't, you know, well recognized as much in the kind of the larger world out there. So, you know, either of you, how are they building these microservices environments?
Microservices, I think it could be built on whether the traditional physical environments to the virtual machine environment, like an IaaS, Rackspace, Amazon's Google Compute, or container model, like using Docker to deploy small container applications using their existing physical infrastructure. So either way, they could build these microservices. It's more along the application path and how people think about loosely coupled applications. So in the past, you would build an application using an application server like WebLogic, and that was a very popular way to build backend applications. And then in that WebLogic application server, you will have numerous modules, right? Hundreds of modules, basically, that provide different type of functionality, connecting and talking to a remote service, talking to a database, authorization logic, is all, and perhaps coordination logic, all like encoded inside one monolithic application. So what's changed is that because it's now easy for you to get hold of a logical server, you no longer have to build these monolithic applications. And that makes actually development cycles a lot faster. So instead of having a coordination service built inside of WebLogic cluster, or using WebLogic cluster for coordination, you would use Zookeeper, right, these days. Instead of having a relational database to store non-relational data, you would basically use Cassandra, which is a federated database to store non-structured data. Instead of using WebLogic to do caching inline, you would use Memcache to do caching. And now suddenly your one application instance becomes 4 different application instances. And so it's this philosophy that's basically what when we talk about microservices, is this philosophy of having loosely network coupled applications that communicates over a fixed network protocol. It's kind of what we define as microservices.
So what are your experiences, Donnie? What you're seeing people, I mean, this seems to be what you're saying, Phil, is it's forcing them to think through that pipeline in many respects. Instead of using WebLogic, for instance, instead of using a relational database, they use Cassandra, right? WebLogic is replaced by Memcache. Is that a common pattern, Donnie?
Yeah, absolutely. I mean, I did some research in looking at Java app servers maybe 2-3 years back now, and it's not what you traditionally think of as Phil was saying, as sort of bleeding edge IT. But if you look at the trends, even just within the app servers alone, you can see this really dramatic shift over time, moving from the huge sort of JEE, like one-stop shop. Here's your huge library of everything you'll use, and also all these things you'll never use, right? Like you want a claw hammer, you also get a ball peen hammer, sledgehammer, a mallet, whatever else. That was sort of the approach. And, people are dropping that pretty quickly. If you take a look at, any number of data sources, and moving to approaches that allow a lot more composition of what you want from the bottom up. If you go to like a Velocity conference today and you say like, well, what are you running your Java workloads on? There's a lot higher chance that people come back with an answer more like Jetty than like WebSphere, WebLogic, or even JBoss than just a few years back even, right? Like people are moving towards these minimal composable solutions where they can sort of tack stuff on top of it like Spring versus having this enormous standard library of tools that they don't want to use, but that they're deploying anyways. So you can see that shift, away from monoliths towards something that you could call sort of a proto microservices approach, right? Like you could say the same thing about Etsy, for example. Like it's all PHP, but I see people consistently making the argument that like, well, it's not a microservice, but you could almost make the argument that each PHP file is a microservice, right? Or we've seen this argument coming out of some of the like ThoughtWorks folks too, of like, well, you don't necessarily have to have a standalone service for it to be a microservices approach. All you have to have is really a standalone jar file that you're deploying, for example.
So it can be very basic.
Right, so you can get a lot of, not all the benefits, but you can get a number of the benefits without going full out to the distributed systems approach. And then you can take that next step, piecemeal when it makes sense versus, for example, saying like, hey, we're all out, we're just like shifting everything to microservices by the end of the year, which is a pretty good recipe for losing your job by the end of the year if you're in enterprise IT.
Yeah. Right, and then one of the key things that as you go through this transition, you're adding more services than you had in the past. So instead of running one WebLogic or two WebLogic instances, you're now running 8 to 10 instances decomposed of what the application was before. This is where you sort of run into operational problems. Instead of traditional monitoring, let you monitor individual instances really well, but they don't do so well when you have multiple instances are running. Like for example, one of the key reasons why you will have more than one instance running for anything is for resiliency, not necessarily scaled, although that's a very good idea to have more than one for scale reasons. If one instance were to go down, you want to be able to maintain your service, at least some service level for your existing customers. You don't want to have outage. And in this world, since your service will remain up and running, the alerts that were generated on per instance oriented monitoring is no longer valid. It becomes more of a noise in this environment. So you have 5 instances, let's just say very simple PHP front end running. One goes down, you don't really care, but you don't really care 3 o'clock in the morning, but should you receive an alert for that? But is 2 going down, should you receive an alert for that? If not, should it be 3? So that is a very interesting question, and that question is different for every single application that's out there. And really, the answer to that is what do you define your metric of customer response time as an example, as a metric that you want to sort of measure against, and then that metric, an aggregate across your entire tier, want to drop to the level that's below the level of SLA that you guarantee your customers, that's when you should be worried. And then that's really where analytics comes in. You can no longer look at individual instances. You have to look at an aggregate signal across all of your instances.
So that was kind of the next question I had then, if we're going to follow this microservices thread, is how is monitoring moving to the center of this new kind of generation of microservices architectures that users are building?
There are 2 things. So one is definitely with the proliferation of microservices, it basically amounts to proliferation of instances. that's running in your environment.
It gets back to that.
Exactly, there's just more of it, and then because the components, as Donnie said, are now decomposed, then that means that it's harder. Whereas before you could look at one instance and trace the stack trace on what's happening between your component libraries. You can't do that anymore. They're now across the wire on remote instances. No such tool ties you an aggregate across multiple instances to tell you what's happening until SignalFx. So that's sort of what we're looking at right now.
Now let's take a quick break before we get back to the second half of the show. Our show this week is brought to you by SignalFx. SignalFx is a SaaS provider for monitoring modern applications. You can find them at signalfx.com. Now let's get back to the show. You know, where we see events like Monitorama, right, where there's like and they're overwhelmingly popular, you know, these discussions. I mean, we're seeing it on the new stack. You know, the stories around monitoring get a lot of attention. Now the people who are coming to the new stack, you know, they're looking at new things and, you know, so on and so forth. But I'm curious, Donnie, what are some of the other factors that makes monitoring so much more, you know, so much more of an important topic for people these days?
It's just sort of a bounce back of, you know, it used to be, we lived through probably 20 years where IT ops were not well respected, right? And in part that was because they couldn't code. And I think, you know, we're kind of bouncing back a little bit, and it could be in part because of DevOps, it could be other things, but we're seeing this resurgence of design sensibility and of appreciation for what the operator experience is like, and not just the developer experience. That just wasn't around, you know, let's say 5+ years ago, right? I mean, you've got tools like the Elk Stack, like Logstash, Elasticsearch, Kibana. You've got, you know, that Monitorama conference you just mentioned. You've got all kinds of monitoring tools built on top of Graphite that have really nice looking UIs that just weren't around before. I think part of it is just, you know, that idea of design, that idea of good user experience has continued to extend past, you know, building good APIs to, you know, being able to effectively monitor, to being able to effectively log, and then to, you know, analyze that data after the fact. You know, I think another part of it too is probably just that, you know, the sheer scale of what we're dealing with now and the sort of transience of servers means you have to have a different visual approach to how you deal with that stuff, and a different monitoring approach to how you deal with that stuff, right? So in some cases, the architecture of the old solutions just aren't well suited for dealing with cloud native approaches to applications. They just couldn't cope with that stuff. We saw that in configuration management, where we had all these new solutions emerging, you know, first in the mid 2000s, and then more recently with like Stealth and Ansible. And we saw it in monitoring as well, where, you know, a new solution, it has the right architecture for the way we're building applications today, but it also has the opportunity to do all the other things right that we've learned since then, but that it's kind of hard to jury rig into pre-existing stuff like Node.js.
Design and user experience. Phil, is that something you think about?
Yeah, absolutely. So I think one of the key attributes of our product is the interactivity and exploratory nature of the tools that we offer. And so if you look into our SignalFx collect the sea of metrics and sea of streams of metrics across the application stack. And you need to be able to sort of tap into this sea of metrics to get a near real-time experience on what's happening with your production environment. So we spend quite a bit of time thinking about, well, with so much information, how do you get to signal as fast as possible? So that's where we have sort of type heads in our product that allow you to quickly get to the metric in combination with the sources that's submitting those metrics easily. We have analytical functions that allow you to aggregate, easily aggregate those metrics into from multiple signals into single signal, And then you could then use additional tools, statistical tools, to transform those metrics to basically smooth out some of the data. And you could do this sort of like we spend quite a bit of time to make sure the user can do this interactively and as intuitively as possible without having to learn a language for them to basically search across this vast sea of data.
So I'm curious how this changes, how views about monitoring change as you're starting to increasingly have the capability to develop and manage applications across, distributed architectures, which really seems to be kind of the big need. And I mean, you cited individual, platforms such as AWS and, and the way you can build microservices on that. But it's still early days, but, the trend really is towards, these environments that work across, multiple data centers, multiple cloud services, to the same, what are the rules that apply? What are the rules that are going to have to change? How does monitoring going to have to be different in those kinds of environments?
Yeah, so it definitely has to be holistic, right? You have to basically cross co-locations as cross-hosting providers. So, for example, Yelp basically have servers in their own data centers that they host themselves, and they have services that's running on AWS. And what they really need is to be able to have a clear, unified vision or view into the production environment, regardless of where they're running. Because for most developers, they care about the service, not where the service is running. They care about whether the SLAs to the request time is being satisfied, not whether AWS is necessarily slower than their data center or not. Although it does matter, but the primary metric is the higher level user-facing metric.
The higher, say that again, the higher what?
The higher level user-facing metric.
Okay. So Donnie, do you have any thoughts about, that kind of treatment that Yelp is having, or any others thinking about this holistic philosophy that that seems to be needed?
Yeah, I mean, certainly there's no question about it that it has to be sort of holistic across like your IT footprint, if you will, right? All the servers, all the data centers, whatever. Like what people really care about is, when somebody goes to the website, are they able to check out, or do they give up before they leave, right? And so that's, I think the other side of holistic, right? On one axis is, does it span the whole footprint? On the other axis is, are you measuring everything that needs to be measured from the bottom all the way up to the top, right? Like shopping cart successes down to, CPU percent, right? And most of the time you don't care about CPU percent, but when you're debugging a problem, suddenly you do care about it, right? The same thing with like free storage. Most of the time you don't really care. You care when you're going to run out very soon, but most of the time you don't really care until you have a problem and you're debugging, and then suddenly you need access to it, right? So it's a lot of these things, you have to monitor them and store them, but you don't really care about looking at them on a day-to-day basis. But I think the really interesting angle, though, is the one about spanning all kinds of different metrics, because it's in many ways a reflection of the ideas behind DevOps and broadening those ideas, right? Of like, how do you build empathy across all of these different groups? How do you get them appreciating what they're all doing and collaborating and working more closely together? Well, you have to build this empathy, right? And it happens sort of at the infrastructure layer with tools like Vagrant that are shared, or tools like Docker, right? That are shared between developers and operations groups. But how do you span beyond that? How do you get back into the business? How do you get out to the customer? A lot of that's going to depend on, monitoring things that business analysts care about, for example. Monitoring things that the company cares about at a business level, looking at dollars and checkouts and all that stuff, looking at the customer experience, and getting developers and IT ops to care about that, right? And then on the flip side, getting, the business side of the company to appreciate, like, well, here's what goes into creating that experience to you. Maybe you learn a little bit more about monitoring than you knew before if you sort of check out this console because you were monitoring shopping carts. Now you know what goes into that, and you can appreciate like, oh, that goes wrong. I can see 3 other things that go wrong. maybe I should call up our IT department right now just in case they didn't notice it, or maybe I should, check if there's a ticket already just in case, right? I mean, nobody wants to get 10 million phone calls right in the middle of a firefighting session, but a lot of times those do alert you to things that you may not been paying attention to, or get you to start paying attention to new things and add new metrics because you didn't realize somebody else really cared about that one. So I think that idea of empathy through monitoring is a really important one.
Empathy through monitoring and consideration of, different factors such as, all those complex interactions, which have so many different kinds of models associated with them in these distributed environments.
Yeah, I think Donnie makes a good point that, in addition to empathy for monitoring, I think one thing he touched on was cross-organization nature of the data that's collected through monitoring systems that we see. So it just, from speaking just purely from SignalFx's experience, one thing that we sort of blogged about was around capacity planning. And so, SignalFx, we have this philosophy where you sort of instrument first and ask questions later. So we have a lot of basic VM level metric that's collected across all of our microservices. And one of the things that we needed to do was, one, as an engineering organization, understand how much capacity was deployed prior to launch. And we need to know that exactly, we have an estimated amount we sort of estimate we'll get a certain number of trials that will come in, and we need to make sure there's enough capacity deployed to handle that around the launch event. So the engineers basically, came up with a set of dashboards that gave them a capacity utilization for each one of the microservices. So we kind of have a nice insight into how that was deployed. And on the business side, which found that interesting, and said, hey, we're running these things on AWS instances. How much is each service costing us? And then they were able to take the same piece of the data, or take the dashboard that engineers created, augmented to get the cost per service. And then that sort of helped give us even more insight into how cost breaks down into individual microservices within SignalFx. So not only that, not only is the data useful for production outage events, it's actually useful for planning events and useful across the organization.
It makes you think of how do you not leave all those interactions on the floor? Because I mean, you can waste a lot of that kind of information, can't you? What are some of the results of what you see when companies aren't actually doing these kinds of things?
Well, I mean, they end up having to, for example, if we didn't have this data in the capacity dashboard available for the finance people, then they will have to go and run different reports, right, against the machines which are being leased, or the machines that should be leased going into the future. And then they will have to basically collect their own metrics on that. They will probably go and ask engineers how much what do you expect what do you expect the number of instances would be 6 months from now, 3 months from now? And then the engineer will have to go back and say, well, let me go find out how many nodes I have now, how many nodes I had before, how many requests am I handling per second using these with these nodes, and all of that is just a long cost cycle. And not only that, the data that they come up with may not be aligned with monitoring data, because typically when you run that type of report, they're usually old and stale, right? So you get a lot more accuracy using live data to be able to calculate utilization and capacity. So those are all sunk costs across departments.
They're losing that view on those complex interactions that are just so numerous now, and and really in any kind of environment, distributed architectures are kind of new, very new kind of idea. But even more common are like one data center. Where are you seeing the failures, Donnie, and how are people fixing those failures?
I think that the biggest failures happen in cases, and I'm going to keep railing on this idea over and over, but in cases where there's a lack of empathy across different teams, that's going to drive a lack of communication, and there's going to be a lot of failure cases in between. Either because they aren't talking to each other about some of the design issues, some of the production issues involved, or because, they're just not talking at all, basically, right? Like, if you're not saying there's a problem, then nobody's going to know there's a problem in the first place. Or, you're not really going to have a clean understanding, for example, of where the interface lies, right? And this is happening, to me right now, right? Like, I just joined a new company. I'm trying to figure out, like, where do I fit into this company? There's a lot of, sort of semi-siloed teams, and you've got to start figuring out, like, what do the lines look like so you're not missing sections, right? And that happens, in every company, right? It happens a lot more often the less empathy there is. For example, we're talking about DevOps all the time, and you say, like, all right, so developers and operations, we can sort of, get together around this idea of, like, infrastructure as code and that sort of thing. But what about developers and marketing? What's the empathy look like there? And generally it's not great. And so you have a really hard problem and a really hard time iterating on, what you've deployed to production versus what the market requirements look like, right? That's an iteration that doesn't happen nearly as often as it should. The iteration that happens all the time is like, we built some code, let's ship it and see if it falls over. And if it does, we'll fix the bug, right? And so, it's really important in trying to figure out where these gaps are. I think the more important gaps, right, are at the business level than anything else. At the level of these different siloed teams at the organizational structure level versus at, you've got IT Ops Team 1 and they're in charge of what's in Data Center 1, and IT Ops Team 2 and they're in charge of Data Center 2. There's a lot more opportunities for empathy there. There's a lot easier communication because, chances are they're all using the same ways to communicate. They're all using, Jira. They're all using, IRC or something like that. But as soon as you try and get, like, non-technical people involved, suddenly they're like, IRC, what is that thing? I'm not going to do that, right? And that's why companies like Slack have gotten so popular, is they're able to, centralize communication in a way that's comfortable for both sides of that divide.
And that's a big part of what SignalFx is trying to do, aren't you? You're feeding all that data, through your analytics platform, so people can consume it through PagerDuty or email or HipChat or Slack or whatever it might be.
Yeah, absolutely. So definitely, like, cross organization. So definitely, like, cross organization is one thing. Also, the cross development group is also something that's very useful as well. So again, I'm going to come back to a little bit about this microservices architecture. So within an application, I'll take our application as an example. We have roughly 17 microservices that's built with 5 different engineering teams here at SignalFx. They basically all look at SignalFx. They look at each other's dashboards that they create. When something were to go wrong, they actually know where to look first before they have to go and contact the people who are responsible for building the applications. So they themselves are much better informed on how to resolve a problem when it arises.
So I'm curious, I thought in the last part of this conversation, I didn't really want to put too much attention on it, but I think it is relevant to discuss as we hear so much about containers. And I'm curious on what the impact is here, because we're talking about microservices environments that, that have been using kind of, traditional technologies, but, with containers, a lot of things change. I'm just curious, Phil, what you're seeing out there. Is the container discussion, different now, and how it, and what is the impact that you're starting to see?
Yeah, I think with container primarily, what that brings around is I would sort of categorize that as a more efficient version of the virtualization transition that we saw a while ago. I think one of the key things that's happening here is with the virtualization transition that we saw years ago, a lot of people consolidated a different type of OSs on a single machine. So VMs gave you that. But in the last 7 or 8 years or so, Linux has basically taken over as a predominant operating server-side OS, I would say. As a result of that, people are looking for a more efficient way of utilizing the hardware they already have to run multiple logical servers on the same physical server. So I think that's where a lot of containerization comes in. But they're using the same ideas around consolidation will be one of the key use cases. and then a flexible way for you to create a logical virtual containers to run your application in much the same way that you could size a virtual machine on AWS. So those are somewhat analogous. The container, what it allows you to do is sort of easily, I think, especially for IT, I would say, that is traditional IT, I would say, who already have a nice large fleet of server that's out there running Linux, to be able to provide an interface much like an EC2 for their customers to run containers rather than running applications which are unbounded on the hardware. So I think that's where the biggest benefit comes in.
Donnie, about the empathy factor. Care to kind of discuss it in the context of containers at all?
Yeah, I mean, I can discuss that, although something I was thinking of when Phil was talking was actually this very different point that I wanted to make. So I'll make that first, then get back to the empathy one. And that's the point that I was thinking about as he was saying this, and one of the things that makes containers very different, to address your initial question, than virtualization. I think this is where things get really interesting, right? It's like, all right, so on the one hand, it's like, sure, they're a little bit lighter weight, they're a little bit faster, whatever, but like what kinds of, and I hate this word, but what kinds of transformations does that enable in the way we build and deploy applications, right? Because that's where it gets really interesting, right? Like step one is, okay, it's a little bit faster, we've optimized. Step two is, oh, well, there's this whole new thing we can do now that we didn't even realize before, right? Which is like what happened with cloud. It's like, whoa, well, we could build microservices, that would be great. We could like scale up and down on demand, that'd be amazing, right? So the thing I think about with containers is like the 12-factor app idea, right? And if you're listening and you haven't seen this yet, just go check it out, 12factorapp.net. And it was written by some of the Heroku guys. I think Adam Wiggins was the main one. But it's about how do you build modern applications, right? What's the best way to go about it? Let's go through these 12 steps. And the one that I find really important here is development production parity, right? Because if you look at the typical developer's laptop today, it's got probably 8 or maybe 16 gigs of RAM. And you imagine you want to deploy an entire microservices environment on that to test things out before you, send things out to your Git repo or whatever. That's pretty challenging to do if you're using heavyweight VMs. But in a world of containers, maybe you can manage it with Kubernetes or something, and suddenly you can spin up like 1,000 containers on your development laptop if you want to. It's crazy, right? Like just as many as you want. There's essentially no reasonable limit to it, unless you're at like Amazon scale and you're trying to replicate the whole infrastructure on your laptop. But I think that's the transformation that it enables, is like a better approach to development, in that you can replicate the production environment almost perfectly by using containers on your laptop and the same containers in production.
Mm-hmm. You know, it's interesting. I mean, I was talking to someone last week about this, about, doing a risk analysis on container technologies versus, virtualization. And they cited exactly what you're talking about, that there's much less of a risk if it is more lightweight, if it is a bit faster, because if you could do things at a much faster pace, you can try different things. And if there is a failure, now you can fail fast. It's not like a slow, painful death, so to speak.
Yeah, exactly. So the speed of iteration is huge, right? That's a great reason to do it. And then the second reason I think is really important is like, there's just no other good way to replicate a really complex environment on your development system if you aren't using containers. Mm-hmm. Right? I think that's an enormous reason to move to containers, right? And something that I think a lot of people probably don't think through when they're doing those risk analyses is what's the risk of staying where you are, right, that you're not appreciating, versus what's the risk of the move. And sure, there's risk involved in the move, but the risk in staying where you are is like, yeah, look, you're breaking code in your deployments all the time, or you've got like some enormous manual test lab that's just like randomly trying stuff to see if it breaks, right? I mean, that's not the ideal approach. It slows down your iteration cycle too.
Phil, any perspectives on that? On that ROI?
Definitely that on the development perspective, Donnie makes a great point that you guys make a great point that we actually ourselves use containers in-house for development on laptops. Yeah, exactly. So we actually run our entire stack inside a Vagrant VM, basically all 17 containers inside one single VM on our laptop for development purposes. And then that definitely has gone us a long way, especially for front-end development. You don't have to have a lab set up in AWS for that. Basically, your laptop, you're self-contained. You could be at a coffee shop sipping coffee and doing development, have the end-to-end test to make sure things work before you deploy it. That definitely is a benefit.
Well, listen, guys, thank you very much for taking some time today to talk with me about this whole, new and interesting kind of realm of monitoring and the impact that that it's having, and in the discussions on microservices and finishing with containers. I want to thank Donnie. Great to have you back. Maybe for the audience, you can tell us a little bit about what you're doing at 451, just to conclude here.
Yeah, sure. So in short, I came over here to lead the team that covers development, DevOps, and IT ops, right? So we're spanning everything from private clouds, monitoring. I cover software development and CI/CD and build pipelines and testing and that sort of thing. API management, even the really traditional stuff, right? Like enterprise architecture, like IT service management, right? Like service desk, help desk, that kind of stuff. So all the way across the map from, traditional IT to the most modern DevOps microservices approach, we're doing all of that stuff. And then I get to work with, it's crazy because I was at Redmond, which is 6 people, and now I've got like different teams of people that do similar things that I'm interfacing with, right? Which is like, wow, all right. And so like there's a separate team of people, well, there's 2 separate teams of people that do like cloud and service providers, and there's like a separate mobile team, and it's like, wow, this is so great and there's a data team, right? So suddenly I've gone from covering everything under the sun to only covering like the equivalent of China.
Well, great. Well, congratulations on the move.
All right, thanks.
And Phil, congratulations to you. You guys recently launched, and you seem to be getting off to a fast start. And it's great to have you on the show and talking to us and providing this perspective. And I definitely want to follow up with you on how you guys are using containers internally. It's a big interest for us. So thanks for joining us on the show.
Great. Thank you for having me.
You're very welcome. And that'll conclude this episode of the New Stack Analysts. We'll be back again soon. Thank you very much. Bye-bye. That's it for this week's show. Thank you very much for joining us. I'd like to thank our sponsor, SignalFx. SignalFx is a SaaS provider for monitoring modern applications. You can find them at signalfx.com. Audio editing and sound design for the New Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again. Hope to see you again for the New Stack Analyst podcast. Bye-bye.